Hello and welcome to the next session of Introduction to Autonomous Systems. If you recall, in the last segment we had introduced the idea of a very simple agent design, that is simple reflex agent, which had simplicity as its main benefit as well as a drawback. We will now look at the next design, which aims to some extent mitigate this particular deficiency in the form of model based reflex agent philosophy. So, let us begin this session. So, model based reflex agent actually aims to compensate for the unobserved state, which means if there is a state which has not been observed for whatever reason, the model based reflex agent now creates a model of that state and stores it in its internal storage system, which means all the states which cannot be observed are being kept through a small model which is run to generate the information regarding that state. Of course, the moment we do this, we realize that now we will need to maintain the history of percepts corresponding to all those states, for the simple reason that it was the previous percepts which generated that particular state, and if you are going to maintain the state, then obviously you also have to maintain or store all the percepts that were received in earlier times. Now, there is another issue which we need to address, which was not there earlier. The state which is not observable was and is due to some actions or some behavior of the environment which is evolving over a period of time. So, now agent also needs to know that how that state which cannot be observed evolves with time, which is independent of agent, because agent is unable to do anything about that state. And more importantly, if agent takes an action, how is that particular state which is not observed going to change? So, now you realize that we need lot more information to be made available to the agent before it can take an action, which is what we have been talking about for quite some time, the right action. So, this knowledge of the world is typically what we term as the model of the world, and this is the model that we are going to store, through which we are going to now generate what the world is or the environment is trying to do, which is independent of the agent, because agent actually does not know about it. Of course, these models can be in the form of Boolean circuits or complex disciplinary theories such as differential equations, empirical knowledge, heuristics, you name it, they all can be considered to be the models that will have to be considered while looking at improving the performance of the simple reflex agent through storing a model. So, if we were to now look at the structure of a model based reflex agent, we will now see all these issues appearing in the configuration of the agent design. So, the schematic on the right hand side shows how a model based agent would look like. Now, let us start with the same starting point like the reflex agent, and that at the current time agent receives a percept through the sensor. Now, the dotted line indicates that there is a partial observability, that there are some states which are not available, and that state now actually reflects what the world is like now. Now, we have a model which have two elements. One is how the world evolves, that goes in and generates the view of outside world, and the second, another model which contains the information about what the agent action would do, and that also goes and ultimately all these three together define what is the current state of the world. So, which means that now current state of the world is dependent on the state which has been stored internally from the historical percepts. Then the two models, one which tells us how the world is evolving, which means the kind of differential equations, the mathematical models, the heuristics, and then if agent took an action, what would happen to that world, particularly in the presence of some states which are not observable at all. And based on this, and then you bring in your condition action rule set and combine these two to generate an action through the actuators which will go and change the environment. So, as we can see, apart from the current condition or the percept, we are going to need the historical state, the models for the evolution of world, and the implication of the action of the agent, in addition to the basic condition action rule set which anyway would be needed for a reflex agent design. Let us see if we can translate this information into an agent program, at least in the context of a symbolic representation. Like what we did for the simple reflex agent, let us now do the same thing for the model based reflex agent. So, we now start with the name of the function as model based reflex agent. It receives a percepts, and please note, in addition to the rule set which was a global variable, now you have the state which has been stored inside. The historical state also is a global variable. The model is also a global variable, and the action is also a global variable. So, suddenly your storage requirements have increased significantly compared to a simple reflex agent where you only needed to store the rule set. But now, apart from the rule set, you need to store the state which is generated from the historical inputs or percepts, the model, the two models that we discussed, and the action. Then there is another intermediate action that we have to do, the step that we have to take, that is, we have to now update the state at every stage, that the state that we have received through our current percept needs to be stored for the future percepts. So, there is now an update action which is required. Then of course, we have to match the rule using the state and the rule set, and based on that rule now we take an action. So, now you require a little bit more processing and little bit more of storage requirement as compared to a simple reflex agent design. Now, we immediately note that this agent is now going to keep track of the current state of the world by using internal model. So, the current state in the face of unobserved state, it will generate that unobserved state using an internal model and then of course take an action similar to that of a reflex agent. Now, having said that, though we realize that this is definitely an improvement over the simple reflex agent which does not have this much of intelligence or wisdom stored into it, we still continue to suffer from some more limitations. For example, we see that the model of the world which is going to use the percept and generate an internal state is never a reality and it is just a guess. Now, one can always say that we can have very complex, very sophisticated theories, very involved models which will come close to what the practical scenario is, but the fact is that we will never be able to capture the reality through any model. It will remain deficient on some counts. Once we accept this idea, we immediately realize that now we are making a decision based on an information which may not necessarily be the real thing or the correct information. And you now realize that if you take an action based on an information which is not correct, then it is possible that the action that you would take also would not be the right thing. And right here we realize that it may not remain what we call an intelligent rational agent, because you might recall we had mentioned that to be rational is to do the right thing, but we immediately see that in the present case we may not be able to do the right thing and consequently it may not remain a rational agent. Of course, we do realize that this model based action is addressing the issue of partial observability, but we have to accept this limitation that it can be inadequate in taking a correct decision. See, there is another limitation of model based action. In fact, this also was the limitation of a simple reflex, but there we did not explicitly bring into the focus, and that action is that there is a lack of knowledge about its goals. Now, here we need to make a stipulation. The stipulation is that if for some reason your condition action rule set implicitly includes a goal, then there is no problem, which means ultimately we will be able to achieve the objective. But in case it is not possible to include the goal information as part of your condition action rule set, then we now become aware of one of the basic limitation of both simple reflex as well as the model based reflex agent, that there is no knowledge about its goals, which means you are getting a percept, you are taking an action. Now, where that action will lead to, the agent has absolutely no connection or no knowledge. For example, if we were to take an autonomous taxi, it receives a percepts in the form of braking light or some other impediment which would involve either braking or speeding up or taking a left turn or a right turn. This will all be based on the percept and the model of the vehicle which has been stored inside the agent, but it could get stuck at a signal it would not know whether to take a left turn, go straight or take a right turn, unless there is a goal which automatically decides that at this signal you need to take a left turn, at some other signal you need to go straight, at some other signal you need to take a right turn. So, these are the kind of condition action entries that the rule table has to have. If it is not there, then it will simply stay put, it just will not know, and maybe you will need what you call a randomization process that we talked about in the simple reflex context, and then it would simply go in some random direction and you would not know where it is going. And the primary reason for this is that there is no destination information given. Now, which means that we need to explicitly bring this idea into the design of this agent, and that brings in the concept of a goal based agent. Now, please note, as we are discussing the various agent designs, these are in some sense recursive in nature, which means your model based reflex agent does everything what a simple reflex agent will do and something more than that. So, similarly, the goal based agent essentially is a goal based model based reflex agent, which will not only contain the model assuming that there is unobservability, but also bring in the idea of the destination or the goal. So, which means our agent programs will now start growing in the way that it not only does the lower level task, but also does the higher level task. So, we realize that there is a need to incorporate information about the destination of the agent into the agent design. So, let us come back to the schematic of such an agent based on the schematics of the other two agents that we have seen, and you can clearly see now that everything else that a model based reflex agent was doing is already part of it, and there are two additional things that have been added to bring in the idea of a destination or a goal. One is what it will be like if I do an action A, which means now there are multiple actions. So, for example, let me just bring in the same idea of a taxi at the junction. Now, it will have to be told that if you take a left turn, you will reach this road, if you go straight, you will reach this road, and if you take the right turn, you will reach this road. And with that information in place, you will then say the goal is to go to a specific road, and that will decide what particular action to take at the signal. Now, you realize that why we need this information in terms of goals and what the action of an agent will do in a given scenario, and that becomes the additional action that we will have to be taking in order to ensure that the goal information is correctly stored and executed. So, now we realize that a model based reflex agent will not only need to have goals themselves, but will also have a connection between the action and the goal through what we call a multiplicity of actions resulting in multiplicity of results, and then based on the goals you will pick the action which would satisfy the goal stated for that particular agent. So, as we have seen, the goal based agent, even though it is essentially goal based model based reflex agent, we do not use such long moniker, we just say it is goal based, but it is including the philosophy of a simple reflex as well as the philosophy of a model based reflex in order to improve the chances of success. This is the fundamental requirement of any agent design. Of course, Here it is worth noting that while some goals can be simple and that a single action could achieve it, there are many cases where there could be multiple twists and turns which are required to achieve the goal, and all of that will have to be then taken care of by the agent design. So, in a given context, in a given task environment scenario, you will need to actually come up with what are all the various actions which together when performed will achieve the goal. And that also brings in an important thing which we have been kind of not taking note of until now. For example, in the previous case when we looked at the agent design, we already had a multiplicity of actions based on which we had to choose a specific action that would achieve the goal. Now, if that problem expands and multiplies many folds, you will realize that you will now need to employ search and planning strategies in order to arrive at a sequence of actions that together will achieve the goal, which means now your agent design, the goal based agent design, not only will have the models, the condition action rule set, but also will need to include various strategies for searching through a large number of possible actions to arrive at either a single action or a sequence of multiple actions which will together achieve the goal. So, now you can see that the goal based agent is becoming a little bit or lot more complex than what we had as a simple reflex agent, and more importantly it is now also trying to significantly improve the chances of the success of the agent. So, what are the features that we should be looking at when we look at the goal based agent? So, the goal based agent operation involves consideration of future, because goal is into the future, it is not the current state, and which means that now we are bringing in the future into the design so that the current actions will achieve what the desirable future is likely to be. And in some sense it is trying to answer a question, what will happen if I do this? That was part of your agent design itself. And now there is another question, will that make me happy? Or to put it in other words, if I take an action, what will happen? Number one, and whatever happens, will it achieve the goal? Because I am assuming that if I achieve the goal, I would be happy. So, this brings it to the question now that will it make me happy? In the reflex based agents that we had, this strategy is not explicitly stated, because this is included in the condition action mapping. Of course, the incorporation of goal related tasks makes the agent less efficient because it is going to take a lot more time, but then we also realize it becomes more flexible because knowledge that supports the decision can be modified. But we have still not reached the kind of agent design that we would like to have, because there are still some limitations for this goal based action. Now, the question is, we introduced a term called will I be happy? It is a qualitative term. How do I measure the happiness? Is there a quantitative performance metric which now I can introduce, which will tell me the level of happiness that I am going to achieve? And depending upon the level of happiness, for example, in some cases you might say it is okay, some say no, it is good, some say it is very good. Now, obviously we need to get to that level of agent design, but what we are trying to now say is that it is not only important to be happy, but also to know how happy. So, in the design of agents, measure of happiness is reflected in the concept of what they call utility or the benefit which can generally be quantified through different means and is not really contained in happiness as a qualitative measure. So, we replace the idea of happiness through a performance metric through the concept of utility, which we will look at in the next segment. So, to conclude this session, model based reflex agent improves upon basic reflex based agent, but has limited success in realistic scenarios. Goal based agent design brings in terminal objective in the agent architecture, but we find that quality of performance is still not addressed and may lead to unsatisfactory behavior or the performance which may not be up to the mark. So, with that we come to the end of the present session. Bye for now and see you in the next session.